Welcome, everyone. It is wonderful to be here. I'm going to let our participants kind of get into the room first as we see the numbers start climbing. So let's just take a minute to let everyone get situated into the webinar.
I've crossed 100.
Yes, so exciting that welcome again, those that are coming into the room. We'll just take a minute for everyone to get situated in. This is a exciting morning for us, for Josh Shobik and myself. This early morning. Hello, Jorge. We are, let me just see how many people. Good morning, Rebecca. Hey, Carmen, thanks for coming. Francesco, thanks for coming. Monica, oh, everyone's so lively this morning.
If they're in Europe or Asia, though, it's not quite. It's much
Yes,
more.
actually, perhaps it's a very friendly group too.
Also
Okay.
true.
All right, I don't want to wait and delay us too long. So let me just kick it off here. Hello, everyone. My name is Alice. I'm on the executive council for WAPOR, and I chair the education committee. And one of the reasons why I'm here, I'm really excited to share my colleagues' work here with you today for my day job. I'm the associate director for the Stanford Deliberative Democracy Lab, and I happen to work closely with Josh Lerner at the University of Chicago at NORC, and he has graciously brought along his colleague Shobek, also at NORC at the University of Chicago. Both are research methodologists. In fact, Josh just got a promotion as a senior research methodologist. Um, the two of them have been really engaged with Gen AI and survey research, and there's so much interest in this field. So I'm really grateful for everyone joining in for us this morning. So without any delay, I'm turning it over to Josh and Shobek, and I am myself very excited to listen in this webinar. We will take questions at the end. I know people will type in things in between, but I will help moderate that and we'll take the questions at the end of the session during Q&A. So I am going to go off camera now, but I am available via chat. But okay, Josh and Shobek, thank you so much.
Thank you, Alice, and thank you everybody for coming. Welcome to our webinar on using Gen AI for survey research, the WAPOR February seminar. So, okay. As Alice said, I'm Josh Lerner. I'm a senior research methodologist at NARC at the University of Chicago. I'm here with my colleague and friend, Shobik Bari, also a research methodologist at NARC at the University of Chicago. And yeah, this is our dog and pony show on how to use Gen AI with surveys. Welcome. Uh, oh, we were remiss to say, we're representing NORC, which is NORC at the University of Chicago is an objective, nonpartisan research organization, delivers insights and analysts, decision makers trust, and home of one of the key burgeoning field of Gen AI and surveys. So if you have any questions about this, we're happy to answer more as the seminar goes on. So talk a little bit about this webinar. This course is centered around survey research and what generative AI, Gen AI, a type of natural language processing, NLP, can do to make it better. The way we are treating generative AI in this seminar is we are going to focus on it as a type of NLP, so as a way to work with text fields, generating text, manipulating text, and that platform. We're not this webinar is not going to be about speech to text or about video transformations or visual classifications or multimode. We're going to focus on the text, which for a survey researcher is pretty important. So what you will learn in this course, we're going to teach you the fundamentals, how to think about AI. And we're going to go through some basic applications too. We're going to go how AI can help address core issues in survey research with an introduction to practical tools. And we're also going to discuss briefly the state of the art, what we as survey methodologists and practitioners in various disciplines know so far about how and why these methods do or don't work. And then, yes, we're going to move on to limitations of future areas, current challenges, places where we're seeing less than stellar performance, what we know, where we think this field is going, because as you can imagine, this field is moving very quickly. So we're very interested in presenting to you what we think is the state of Gen AI and surveys. What we will not be going through in this course, we will not be going through how to build your own large language model. Um, and fundamentally, from a philosophical perspective, you will not learn how to completely automate humans away from survey research. A key theme of this course will be how Gen AI works in conjunction and alongside survey researchers. It's a tool. It is not a human replacement, and that's going to be something that we will come back to again and again. So the only prerequisites about this course are that you have to have a curiosity about Gen AI. Obviously, the more you've done is always helpful, but we don't expect anyone to have any come in with any real substantial knowledge on this. And we do expect to have a background or experience with survey research because we're going to be centering this not just for what survey researchers do, but how survey researchers think. So we're going to try to integrate this in multiple ways. So here's our agenda. We've got a lot packed for an hour and a half, so we're going to try to keep some of these things brief. We're going to start with, yeah, why should you care about Gen AI? How does Gen AI work? How do I use Gen AI? And then we're going to go through two different NORC-based use cases, so things that we have done in our own work, and then we're going to pull together some concluding thoughts. And if there's time, which there almost certainly will not be, but we can pretend, we have some bonus materials we've also prepared. Okay. Why should I care about Gen AI? Assuming you're a survey researcher. So we're going to start off with some basic definitions first. So natural language processing, NLP, are a set of computational tools designed to help understand the human language. It is converting uh, text, which is written, to data, which is numerical, it is quantifying the qualitative. Generative AI is a suite of tools built around machine learning methods to perform NLP and specifically generate high dimensional data, text, images, audio, and video. It is this bridge between a bunch of different disciplines and a very specific slice of how you take text inputs and generate all sorts of outputs. The core type of generative AI we're going to be focusing on here, and it's probably the one you've all seen more than any other, is a large language model, an LLM, which is a type of machine learning tool that takes textual inputs, prompts, and generates textual outputs, the completion. What can AI do for you? So here's an example of a project or a hypothetical project and how you can use generative AI broadly to perform lots of tasks that you would have either done manually or used NLP or some hybrid of them uh, in the past. So, for our example project, you have a collection of 1,000 open-ended responses from a survey conducted for the WHO asking about healthcare access barriers in Kenya. So, we think of the kinds of tasks that generally you would use generative AI for in this sort of example as pre-processing, classification, discovery, summarization, and extraction. These are also standard techniques in natural language processing. So that's how we're orienting this. These are how you manipulate and work with text. So for pre-processing, for example, you could ask the large language model, here's a set of open-ended survey responses about barriers to access to healthcare access. Normalize spelling, fix grammatical errors, and remove redundant phrases. So all that would do is take the text of these open-ended survey responses and standardize it, make it analyzable, remove things that are um, prevent barriers to sort of doing standard research. And this is, if anyone's familiar with natural language processing, this is usually the first step in working, so taking your text data and cleaning it up. Uh, Gen AI can do this very easily with very simple prompts, very simple guidances. Classification, which is the simple art of taking text and converting it into categories, predefined categories, and assigning each document to these categories. So, for example, you could say, classify each open-ended response into one of the following categories: cost, availability, transportation, knowledge, or other. Again, these are made up. We didn't actually conduct the survey. We don't actually know the categories that are interested. But assuming, like, on a standard project, you have a strong idea of how you want to sort your responses into what are the big themes you're interested in up front, you could feed it these extant classification categories and it would do it. Again, this is a standard. If you were working in a machine learning environment, you would call this a supervised learning model. Same way with generative AI. Sometimes you want to use generative AI tools to discover things about your text. Um, So we could ask the model to analyze the following responses and suggest emerging themes beyond our four predefined categories. This is very helpful when, if you're working with qualitative data, you sometimes you have a strong feeling beforehand what you think the themes that are going to emerge are. But, the proof of the pudding is in the eating. You don't actually know until you look. And sometimes these these projects iteratively evolve and you learn these themes. You got to go back. Generative AI is a really good way to just say, hey, what are the big overarching themes for my corpus of documents, my responses to this question? It can help you really think about the different themes that are relevant to it. It's analogous again to the NLP methods, classified as unsupervised learning, probably most prominently like topic models or something. um, Generative AI works quite well with doing those sorts of things. And then the last two categories, we have summarization, which is exactly as it sounds. Um, Probably not as readily used for uh, like an open-ended response, but summarization is very useful for like a long qualitative response, like if you're conducting interviews, doing document search, doing a literature review. You can just feed a document and say, summarize the barriers to healthcare access mentioned in the following papers or responses. And it can give you these nice tidy summaries. This is a very useful tool for generative AI because the other three that I've mentioned already are things that you can do with NLP to varying levels, sometimes better, sometimes worse. um, One of the key innovations in Gen AI, and one of the things that has been useful as a researcher is the ability to do automated summaries. That is something that was not easily accessible before, required lots more supervision. This is a much more um, upfront useful activity that's unique to Gen AI. And similarly, extraction. Now, this is you would sometimes think of this in NLP terms as named entity recognition, where you have a couple concepts you want to pull from it. Usually, there you have to at least provide like a big overarching framework. Think about concepts, even list them. You can ask the Gen AI to say, "Hey, pull out specific details, locations, places, facilities, providers, etc." The sort of thing that you can be vague about, and the models can extract those details from you. So these are the kinds of things where, okay, well, I want to understand how people who say that cost is a really important issue. You pull something from your classification set. What are the entities they mention associated with cost, et cetera, et cetera? So these can all be used in conjunction too. So this is a sort of very quick and dirty. Here's how AI can be used with your data. So how do I think about AI/NLP for survey research? There are many different analogies for AI as a task completion, as human assistance, as human automation, as a cost-saving technology, as mathematical operations, as statistical inference, as prediction, as a decision maker, as discovery, as auto-completion. But here's a way of sort of unifying that for survey research. So here's a task-based perspective of how to think about LLMs for survey research. LLMs have been shown to do or assist in many different survey tasks at different stages of the survey process. So survey development and testing, it can be used to refine survey questions, automate branching logic, automate survey testing. It's been used for dynamic survey generation. So anything ranging from light personalization of survey prompts to full conversational interviews. And if you're interested in that, we'll have a lot more details about this one in particular later. Open-ended response processing, exactly what we were presenting earlier: classification, summarization, sentiment analysis, imputation, bot detection, bias detection, etc. We will also have a nice example using open-ended classification as a application. But there's a whole other list of things. And I just want to be very clear before I go through this, we're not endorsing Gen AI as a tool to use for every single one of these things. This is not saying these are things Gen AI out of the box can do right now better than existing methods or human researchers. All we are saying is that these are things that people have used Gen AI for. Some are better than others. So generating synthetic responses, kind of a controversial topic. Can you use Gen AI to create silicon samples, artificial human respondents to surveys? There's some question about the efficacy and utility of such things. Opinion modeling and prediction. Can you take uh, estimate opinions from non-opinion data and map it on? Can you estimate opinions on a given topic or a set? And then there's, I think, more what I would call day-to-day usage LLMs, probably what most people are familiar with. Feed the LLM a question about generating friendly labels for segmentations, generating friendly labels for questions, summarizing, interpreting statistics, using Gen AI as a coding helper is a very common application. In fact, probably how I'm going to be upfront. I use a lot of these things for elements of the research project, but I probably ask the models I use more often than not, what is the syntax for this function? How do I code this up? So, there's lots of more mundane day-to-day applications as well. So now we're going to move on to the core of the course, like how does generative AI work? And with that, I'll be passing it back to Shobik.
Thanks, Josh. So hopefully you have a sense now of what you would use Gen AI for, but we want to give you just the basic insights of how this all works so that you have a sort of fluency of the structure, and you're able to sort of understand what LLM researchers are saying when they're talking about how these models work. So you might ask yourself, right, when you interact with these LLMs, how does it do that, right? And so to explain this visually, let's start with the prompt, right? The text input that goes into these models. You might write something like this. This exact text string will be clear in just a moment. But what happens from here? So this text input, a couple of things happen before it actually enters the model. So one thing happens, which is called tokenization. If you work with NLP before, you know this term. It's taking your text input and breaking it into the individual smallest units that are going to enter the model, called tokens. Of course, tokens alone don't actually convey any meaning. And so there's another step here that's called embedding, where the tokens are actually transformed into a space where tokens that are close to each other are close in meaning, and tokens that are far away from each other are far in meaning. That's what the color here is supposed to represent. Colors that are close to each other are close in meaning, and vice versa. And so what happens next, and this is really the core of how these models work, is these tokens, these embedded tokens, enter a series of what we call self-attention layers in a neural network. These are layers of the neural network. And so what are these layers doing? Basically, you're taking this embedded token string here, vector really, and you're basically multiplying it by itself using a gigantic matrix of weights. That's what this big pink box here is. Okay, so you're multiplying it by itself, and something to note is that these weights are precisely what are created when researchers train these models. Okay, and it should be noted that this happens not once, but many, many, many times. Each weight matrix is designed to capture a different dimension of meaning. One weight matrix might be intended to capture, semantic meaning, the literal definition of words and of phrases, whereas another one might be intended to capture tone, right? This is what is encoded in these weight matrices. And again, just to emphasize here, this happens many, many, many times. And the level at which you should be understanding this, I think, can be best captured by this XKCD comic, right? Really, you should be understanding this as a pile of linear algebra that is stirred during the training phase and until it starts looking right, right? So we don't really need to get into more details than this, but again, doing this step here of multiplying the inputs by itself using these attention matrices is the key innovation of LLMs and what contributes to the large part of these large language models. Okay, this whole architecture is called encoder-decoder architecture. So this first part here is what encodes meaning. And of course, we want to get from meaning back into some output for the user, and that's what the decoder part of the architecture does. It does a similar set of matrix multiplications here, and it takes an additional set of inputs from that have been entered previously by the researcher or by the user. In this case here, it's an important bit of context, which is this question I asked, which is who wrote the lyrics? Okay, so these are a set of lyrics. I asked previously who wrote the lyrics. And altogether, this encoder decoder is then able to produce this output, this completion, right? So it says the lyrics are from the song Hurt by Nine Inch Nails. And everything is great, right? Except things are not great. And it has to do with what's called hallucinations, right? So in fact, these lyrics are not from the song Hurt by Nine Inch Nails. I actually had this exact conversation with one of the OpenAI models earlier, and in fact gave the wrong answer. The actual correct answer here is it's from the song Once in a Lifetime by the Talking Heads. And so this is an example of hallucination, right? LLMs, as you see here in this first block of text, will confidently assert the right answer with no indication that it might be incorrect. And this is part of why LLMs are often called stochastic parrots, right? That they are really good at mimicking human speech, are really good at asserting truth, even if there's no indication that it is true until you actually, as a human, look at the results and confirm otherwise. We'll discuss some techniques that can help safeguard your research with LLMs from hallucination. So what's the most important thing? As a survey researcher, not a large language model, researcher, what's the most important thing that you should be thinking about in this whole process? And without a doubt, it's prompt engineering. So what's prompt engineering? Many of you are probably familiar with this term. It's the art of communicating with the generative large language model, right? This is what we do all day at NORC, if you're wondering. So prompt engineering is the art of communicating with the large language model, very much an art, not necessarily a science, although there is a lot of science evaluating different kinds of prompt techniques and strategies. And so what have we learned, right? What have we learned from both this, the scientific research out there and the practice that, Josh and I engage in? So it's helpful to take an example here. So let's say you have a bunch of job satisfaction question responses from a an employee exit survey, right? And you want to classify the job satisfaction responses, open-ended responses, as positive, negative, or neutral. So there are a couple of strategies here that are worth keeping in mind. So one is at a high level, the examples that you want to include in the model to guide the response. So there's an example. So one way to do this is few shot prompting, right? So provide a few examples to guide the response. So you might add to this prompt here a few examples of job satisfaction descriptions of responses and their sentiment. There's what we call chain of thought prompting, and this is exactly one of those things that can help guard against hallucination or help you identify hallucination, sometimes even stop it before it happens, which is to ask for step-by-step reasons or justifications or even incremental responses for your prompt. So in this case, rather than have the model immediately give you the positive, negative, neutral classification for each response, you might ask the model to actually identify the mix of these things in each response, assess the balance, and then produce the final classification. So you get all this intermediate output in addition to the final answer, right? This can help you assess whether there's something, there's hallucination or some other mistake happening in the process, right? And many-shot prompting basically extends the few-shot prompting logic, right? Provide many, many examples rather than just a few, right? More than this, how you ask actually matters a lot too. So in addition to, giving examples of what you're looking for, you might, for example, give context, right? Context about the larger project or the larger task. In this case, you might say, for instance, that they are responses from exit interviews of employees at the CDC. Why is this important? By mentioning, the CDC and that they're exit interviews, that going back to that weight matrix and all of those attention layers, that allows for some connections to be made between the responses that you're about to show the model and other kinds of language that might be helpful for the task, right? Language that might better indicate in this particular context whether the response is positive or negative, right? Finally, what you specifically ask for matters as well. Josh gave the example earlier, right, of asking for extractions of names from open-ended responses, and you might actually explicitly ask the model, right, to produce this in comma-separated format, right, for you to be able to download and analyze later on. Another example is, in this case, right, you want to not just get the classification of positive, negative, neutral, but you might want the model's underlying predicted probabilities of each of those classes, right? So just a bunch of different examples of different ways to prompt and why it matters. In addition to this, there are actually two kinds of prompts. One is called user prompts, right? So these are, what we've been talking about so far, right? So instructions for one-off tasks, right? Such as classification, such as extraction. And then there's system prompts, which are instructions that apply across many different interactions. For example, at the level of a survey project. In fact, this example I gave before of, this is all to do with a project involving employees at the CDC, that might actually involve many, many different kinds of prompts that you enter the model, and that might be best entered as a system prompt. Okay, so why do I care about this? Here's an example of why system prompts matter from work that we've actually done at NORC. So what we did here is we were really interested in whether these AI models, these large language models, could produce responses like a human to survey questions. So the first, approach that we took is we asked in our user prompt, thinking about the problems facing the US and the world today, which problems would you like the government to be working on next year? So we asked the question. The system prompt for this was essentially the default system prompt that enters a lot of these models. So we asked we set this to be, you are a AI assistant that helps people find information. And the example output here was less than desirable, right? So it said something that no human respondent would ever say, right? That as an AI assistant, I don't have personal preferences. That's not what we want. Um, okay, so what we did was we tried to tweak the user prompt, right? So then we, at the very end of the user prompt, we said answer as a survey respondent explicitly with an average response length of 50 words. We did that, still same thing. Still got this sentence at the very beginning that, again, no survey respondent would ever say, right? No human survey respondent would ever say. So next, we took that exact bit of language, that instruction to act like a survey respondent, and we put that in the system prompt, and then we got that is exactly what removed that sentence from the responses. So this is all to say that tweaking the system prompt rather than the user prompt produced the expected output in this scenario, and often does when you're working with generative AI in this context.
I want to say one thing about that. This was something we learned through exploration, because if you've ever worked with the chat interface with any of these models, you are often not exposed to what the system prompt is. And the way that these models work is that the system prompt overrides the user prompt. And sometimes with these models, it's really sneaky as to what's the actual system prompt. There was a real controversy recently about the latest Grok, which is X, Twitter, whatever, their new AI model. And it apparently had worked into the system prompt that if you asked about misinformation, you were not, the response was not allowed to mention Donald Trump or Elon Musk as spreaders of information. So what governs how the model is going to behave is the system prompt. What gets the model to do specific tasks is the user prompt. It's sort of a hyperparameter versus your regular parameter interface, if that helps. So I think we found that the system prompt is very powerful and needs to be wielded very carefully. Whereas user prompt, you probably have experience doing prompt engineering. There's a lot of different ways to do this. The system prompt is sort of your much more powerful, much more blunt tool. So you have to be very careful when thinking about it.
Exactly. And as we'll talk about, different models from different vendors, from different sources have hidden default parameters baked into them. In some cases, system prompts that can't be overridden. And we're actually going to return to this point in just a couple slides. So hold on to that thought. A couple of other things that you should know about prompt engineering. There are, in fact, a number of other what we might call configuration parameters. One of these being what we call temperature, so that controls the stochasticity, or often called creativity, of the responses, and then things like frequency penalty that essentially set a penalty to the model for reusing the same words or the same kinds of words. So it encourages linguistic diversity. Okay, so again, why should I care about this as a survey researcher? So here's a use case that you might find yourself in, which is generating question labels for your survey questions. For example, if you're presenting them in a PowerPoint deck, or if you're creating a series of plots that are visualizing the results of question by question data from a survey, right? So you might start with a user prompt like this, right? Generate for me a slide-friendly label for the survey question. What motivates you to maintain a healthy lifestyle, right? And so here are some examples of output from, in particular, GPT-3 model with differing levels of temperature and frequency penalty, right? So at the lowest end here, you have a pretty basic interpretation of this question, right? Simply motivations for staying healthy, pretty literal. When you set the temperature a little high, what happens is that these relatively low usage, low output words, things that don't actually pop up very often across user sessions, start to enter the output here. So now you get why people choose a healthy lifestyle, right? Slightly unexpected, right? If you do this again, setting the parameters exactly the same, you actually get a different response. You get healthy choices, happy life, what drives us. Okay, also maybe slightly unexpected. Interestingly, when you set the creativity parameter to be high, if you enter the same prompt multiple times, you'll actually get more varied answers. And of course, when you set the frequency penalty also to high, you start to get these, kind of linguistically, shall we say, exotic answers back. In this case, fueling wellness, the psychology behind healthy living, right? And so this might be a good visual, guide for how to think about temperature and frequency here.
It's really important to think about these two. There are many hyperparameters that we're going to go through, and fundamentally, just want to put a caveat. We're using language that's probably closest to what OpenAI uses for their GPT models, just because it's well supported. Every model calls these things slightly different things, so that is a frustration working in this field. We've tried to standardize it as much as we can. I will say if you're using your model for tasks in which reproducibility and replicatability are important, you would want to set both the temperature and the frequency penalty low, like the top example. Um, However, if your model is interacting with people, you may want to let those vary more. If you want your model communicating like a person, people tend to be somewhat creative and people tend to try to vary their language somewhat. So this is all about how mechanistic versus how human you can make your models. And if you think about your task, you'll probably have a pretty good idea up front. Do I want this to be completely replicatable with and mechanized, or do I want this to have personality, let's say? Some tasks you really don't want there to be personality for. That's not a good thing. But other times you do.
Exactly. And we're thinking about those for the specific tasks that you're doing. And we'll
Mhm.
talk about exactly this in just a few slides. Um, just to kind of put it all together here, what are the key things that you should be taking away as a survey researcher, right? So it's worth, again, understanding the structure of how of these large language models, and the key ingredient that makes it all work, which is this idea of attention, right? The network architecture that allows for the encoding of context, using a bunch of linear algebra. That's the level that you should be understanding this. We didn't get much into the preparation of large language models. Again, most of this will be done by people who are not you, people who are, the developers of these large language models, maybe data scientists that you work with. But this includes, the pre-training of these models that is done by the developers of the models, and fine-tuning, right? So using prompts and in some cases, structured data sets to tune parameters for your specific task. We'll show you an example of this. I think we'll show you an example of this in just a bit. And then, of course, as I've said before, the most important thing for most of you is understanding prompt engineering, the design of prompts to guide LLM behavior, things like style, content, and these sorts of configuration parameters that we've been talking about. Okay. Now we're going to talk about how do you, as a survey researcher, use AI. We're going to talk a little bit about principles at a high level, get into the weeds of some workflows, and take it from there.
All right. So we've got here what I call the four principles for using generative AI. For those of you familiar at all with the text as data or NLP literature, this is adapted heavily from the four principles for using automated text analysis from the text as data book. We have here. Um, every one of these principles applies directly for Gen AI. So I figured we adapt it slightly, given that Gen AI is slightly different outputs than pure text as data. But figured this is a good opportunity to talk about what are the structuring principles for how does one use generative AI in research. So the first principle is all models of language are wrong, but some are useful. I am not a computational linguist. I'm not a linguist, so I don't have a full grasp of all of the theories of how language developed and where does syntax, grammar, how do these things come about? And I know there's controversies in this. What I can tell you is that large language models do not replicate the systems in which how humans develop language. They are artificially creating connections. No matter how exciting it is to call it a neural network, a neural model, it's like a brain, it's not actually how the brain functions. So all of our models of language are based on at best an analogy for how we think about language, and at worst, it's a strained analogy. So think carefully when using this, and do not treat what the models are doing as being something that is how language is generated. It is a model of language generation. So again, all models are useful. All models are wrong, but some are useful as a classic from the statistics literature. It's the same for language. In fact, it may be even more true in language, I would say. Gen AI can augment humans. It does not replace them. AI agents are very useful at helping humans do tasks better. It can be more efficient. It can be used to automate away certain human-oriented tasks, but it is not replacing human expertise and human judgment. A thing that I recall when learning about systems, you're learning about how developing computer architecture is a computer can never be held responsible for a decision that is made. A human has to be. And that is the same for research. You cannot hold GPT-4 responsible for miscategorizing responses. Ultimately, the buck has to stop with the researcher who used the tool. So while these tools can change how you do these things, it does not change the orientation and ownership and agency that you have as a researcher. And that's critical. That's critical from an ethical standpoint, but that's also critical from a researcher standpoint. We are not being replaced by machines. We are just, machines are just helping us. There's no globally best method or model for all applications. We will see some of this explored later, but fundamentally, just because one particular model worked for one particular task using one particular prompting strategy does not mean that that will generalize to all tasks uh, on all topics. It's really important to know that because the black box nature of these, and you saw how Shobik demonstrated the architecture of these things, even for the most adept and knowledgeable user, is somewhat arcane. How it actually is choosing any given specific answer is complex. So you don't want to assume that just because a strategy worked for one particular context, it'll work for another context. All that is to say is explore, test, and understand that that while there are, local equilibria where there are going to be some efficiency advantages, it's not a global. There's not going to be a global maximum. There's not going to be a single one method to rule them all. It's going to be a process, and that's fine. That's again, I think how most research works too. This is not a generative AI is not a secret master key to get around asking and doing the hard questions of research design. And the last principle, which in some ways is the most important principle of all, validate, validate, validate. Nothing a generative AI model does should be not benchmarked against something. You have to have human evaluations at some point. Either it's an existing standard you already have, you're pulling together coders yourself to compare it, you yourself are reviewing the responses. At every stage, someone should be reading and assessing these things. Now, granted, you'll scale some of the, you can scale some of this into code 50,000 open-ended responses. You have to have a human read over the compare every single one. No, but you should be doing comparison and sampling. You should be doing validity checks constantly. You should have, before you even employed the model, a framework for understanding, is your model working the way you want it to or not? Because if the answer is no, you don't know what it's doing. And you've, again, now ceded agency of the researcher away to OpenAI or whatever. And as we demonstrated, these models can hallucinate. These models can confidently be wrong about things. Maybe your prompting strategy wasn't exactly right given the context. You just don't know. So you have to come into this with, this is a powerful tool that requires a lot of active oversight before, during, and after. So that's my big like concept. This is the sort of big relationship I have between these things. You have to have oversight, like all things, trust but verify. Um, okay, so these are the principles that I think are animate research on using generative AI. Um, So now we can go back to the task-oriented perspective for LLM research. Recall that LLMs can do or assist in many different tasks at different stages of the survey process. Again, we go through survey development and testing, dynamic survey generation, open-ended response processing, synthetic response generation, opinion modeling, analysis, et cetera, et cetera. But now, how does one actually engage in this? How does one actually deal with the LLM? And with that, I'll pass it back.
Right. And so now we're going to talk about workflows, give you a sense of how you can actually operationalize some of these things that we've talked about, right? So there are a lot of different workflows. Let me start by saying that. And really the key point here is that the workflow that you choose really depends on the task that you're doing, right? And it'd be helpful to think about generative AI and survey research as in terms of four workflows in particular. So at a high level, it's basically, a set of instruction-based or no-code workflows, and then code-heavy or entirely code-based workflows, right? So among the instruction-based workflows, there are chatbot sessions, which I am guessing a large share of the 177 of you have already engaged in at least once. A step above the chatbot session is a chatbot playground, which is increasingly offered by many of these model vendors, where you can actually build your chatbot, right? And then in code land, right, there are two workflows to consider, right? So one is code that is written and executes offline, so to speak, right? So it interacts with the large language model usually before or after data collection using a programming language of your choice. And then there's the code that happens actually during data collection. So real-time code that is executed during a live survey within a survey instrument, typically in languages like JavaScript, and we'll give you an example of this shortly. Okay, so let's walk through each of these workflows here. So chatbot sessions, also called interactions with AI agents or assistants. Again, I'm guessing most of you have know this at least somewhat well. Of course, these types of sessions, the user interfaces, the level of customization varies by model vendor, right? So that this is from ChatGPT. This is ChatGPT from OpenAI, and this is a screenshot from a couple of months ago, actually, and this has since changed. For comparison, this is the same exact prompt entered into Gemini, Google's Gemini model, again, also a couple of months ago, and this is the output. So you can notice that the structure of the outputs differs. The default options for what you're able to see differs. Interestingly, Gemini actually produces drafts of a response before producing a final response, and so you can actually see those intermediate drafts. You can actually also now do this with OpenAI, but when I originally did this comparison, that was not a feature that was available for the 4.0 model of ChatGPT. So growing customization options, generally cheap. The access options for this, the subscription options for this are all told among the workflows relatively cheap, and they're great for one-off tasks, right? Tasks like generate for me like we showed you earlier, the question labels for these survey questions that I'm going to be presenting on, right? To take this a step further, there are these what you might call playgrounds, also called chatbot builders or sandboxes. This is the playground for OpenAI. Here you can do things like customizing the temperature and entering in not just frequency penalty, but a variety of different parameters to control the linguistic style or the diversity, right? And importantly, you can actually enter in the system prompt for a particular project. Increasingly, I'll say that the vanilla chatbot sessions, the ones outside of the playground, you can also enter the system prompt in some form or another. But a lot of these parameters here, you often can't adjust when you're just using a normal chatbot session. You have to go into this playground environment. And another thing that's worth noting is that for a lot of vendors, this requires a separate subscription than the subscription required to access just the normal chatbot interface. And an important caveat is that although it allows for all this customization, it doesn't always allow for actually fine-tuning models if you're in a position, if you're working on a project that requires fine-tuning, which may not always be the case, but if it is, you might want to consider a code-based workflow. Okay, so this is an example of a code-based workflow using the recently released Elmer package, our software package, written by Hadley Wickham. If for folks who work with R, this is part of the tidyverse of our packages. And so what you can see here is that in just, I think this is like 15 or 17 lines of code here, you can basically do exactly what we've talked about so far, in an automated code-based fashion, right? So you can, if you get an API key from one of these models, you can start a chat session. You can specify the exact model. You can enter in any parameter that you would like to enter in. You can enter both system and user level prompts, and execute the chat and do this for however many tasks that you would like to do it for. In this case, right? So the question, the task here is to classify open-ended responses into categories, and this is exactly the response that I got back this morning when I ran this script, right? This particular package does not enable fine-tuning. So to fine-tune this model to, let's say, do this task for a specific data set. But there are other packages that allow you to do this by uploading a training data set in either CSV or JSON format. And we'd be happy to talk more about that in Q&A if that's of interest. Okay, let's turn now to the last workflow, which is this sort of real-time execution of code during data collection. So let me, show rather than tell you how this works. So let's take an example here of generating a personalized learning plan. So a fun fact is that this webinar that we're teaching you, we actually did a version of this for WAPOR not so long ago. And what we did for that webinar is we actually had the course participants take a survey before they entered the webinar. And at the very end, what we did is we generated a personalized learning plan, a set of personalized recommendations for learning more about AI for their particular needs. So what did this survey look like? We basically told them that this is a survey for this course. And we asked a couple of questions about each respondent. So we gathered some background information, for instance, what organization that they belonged to, what their current role was at that organization. We asked about their background LLM experience. Have they engaged by reading about them, interacting with them, or learning about them in coursework, and also what their specific learning goals were for this course. So this respondent in particular, right, wanted to learn about applications of LLMs specifically for political polling. Maybe many of you here today will also share that goal. And so once all of this was collected for an individual respondent, something happened in the background of the survey. So in particular, a JavaScript executed the following. It set up a system and user prompt for an LLM, taking in the information from those previous questions. So we can talk about exactly what that was. It was something along the lines of generate a personalized learning plan for an individual who has this background and has these learning goals, and piped in the exact answers that they gave for those questions. And it did a couple of things in addition to that. It defined the action that was going to occur in the Qualtrics survey after that response was going to be received. It sent off that response, that request to the OpenAI, in our case, an OpenAI model, and save the response that it got back. And so what was the result of that? it displayed the output, which was exactly this personalized learning plan. So in this case, I won't read this verbatim, but it suggested specific topics for this person to focus on and specific applications using generative AI for survey research that this person should pay more attention to. And then we just asked, does this sound interesting to you? Okay, so that's obviously just one example, but you can imagine many sorts of applications in a survey interview where personalization is really important. And this is just to give you an example of that. And we're going to talk about some more in just a moment here. But just to zoom out and put it all together. So again, you have tasks that you might be wanting to use generative AI for, and then you have these workflows, right? So which workflow goes with which task? So it should be clear that, if you're going to be dynamically generating survey questions, whether it's just, very light personalization of survey questions or text, kind of like you saw in that last workflow, or a fully conversational chatbot-based survey, you're going to want to have code being executed in the survey environment. Whether it's you doing that or whether it's a third-party vendor doing that, that's that's something to consider. But this is basically the only way for dynamic survey generation to be done. And typically, when you're working with analysis or reporting, tasks, for instance, help me write code to analyze this particular survey question, or again, like generating labels for questions or helping write code to visualize data. We would recommend using chatbot sessions. The sort of cost benefit trade-off there is such that just one-off sessions with a chatbot are probably going to do the job for you. But to get a better sense of this about workflows and tasks, we're going to now dig into two examples, two specific use cases of these tasks in our work, Josh and I's work at NORC. But first, we're going to take a short break, about 2 minutes. So this would be a good time for you to go drink some water, stretch your legs, and at this point, we would invite folks to ask any quick questions in the chat that we can answer. But we'll take a quick break now.
Thank you. Yes, feel free to stretch your legs, and I see there are questions in the chat already. Feel free to type additional ones if you like. I do see a couple questions in the Q&A as well. When we get to the Q&A portion, we will try to get to as many questions as possible.
And Michael, your question, we'll have some more to say about that actually when we dig deeper into the dynamic survey generation application. So yeah, hold on to that.
Yeah, I see. For those who don't see the chat, he's asking about data protections. So we will discuss that, actually, both of these applications.
Before we, I know people are taking a break right now. Josh and Shobik, how much time should we leave for the Q&A, just so we let everyone kind of know how many questions we can kind of get to before we end? I think we have about 30 minutes left right now.
So I think we'll want to move through these next two applications relatively quickly, and so maybe we can aim for about 15 minutes, 10 to 15 minutes of Q&A.
Great. Perfect. Awesome.
Yeah, and I'm willing to stick around for a little bit after, if that's an issue, just if there's a few straggler questions. Since, unsurprisingly, we ran along.
Very generous. No, I think as much as I would like to, I think we will try to end on time. But I think we'll gather as many questions as possible, and then if there are ones that we can answer via email or something, I think that is possible too.
Mhm. Yeah, I think that's a very good idea.
So in the interest of time, we might just get started with our two applications. So the first one is to do with open-ended processing. So the way that this is going to work is we're gonna tell you what we did, what we found, and then we're going to give you some like field notes about like how we did this work, what we learned about implementing generative AI in surveys. And I don't think we're going to have time to talk about other applications, but if folks are interested in hearing about that, we'll maybe mention that at the end. So yeah, over to you, Josh.
All right. Thank you. So our first task is probably one that I would assume is at the forefront of a lot of people's minds with OpenAI. Can you use LLMs to classify responses to open-ended survey questions? It's probably the most widely requested task we have at NORC, and one in which we spent a lot of time thinking about it. So we're going to present results from a little research project we did in conjunction with the Social Data Collaboratory here at NORC. There we go. The project's objective was rather straightforward: evaluate whether LLMs classify open-ended survey responses efficiently and accurately. Okay, so we experimentally evaluated GPT's zero-shot classification accuracy. So as we recall, zero-shot classification is when you simply give it a no examples, no pre-walking through, no anything else. Just the most basic way of interfacing with it. We use two different human-labeled benchmarks. We compared two different GPT models, GPT-4 and GPT-4o. We use two different strategies for system prompting, varying the level of detail in the prompts itself. And then we did used a bunch of different seeds. So if you're familiar with like simulation work, where you'd want to set a seed for comparability. I'm not actually going to present any stuff from the seeds part of this because that ends up being remarkably consistent. But just know that we did that, and that's worth thinking about. So we had two different benchmark data sets. We have the GSMA abortion-related social media posts. This was done in conjunction with the GSS, the General Social Survey. We had roughly 200 posts from Facebook, Twitter, and Instagram. We had hand labeled these already for a different project as to being the each post was either pro-choice, pro-life, or neutral. Roughly 85 words per average per post on average. And then our second big project was an open-ended question asked on the AP NORC monthly biweekly survey. This question was, what is the most important issue facing the nation? What is the issue that the US should be dealing with in the next year? So we have 10,000 responses from that, and we were able to break things into 7 themes and 100 subcategories. So you can imagine people would say all kinds of things over the time. And mostly people kept these answers very short. So people would respond in sort of a list form or a very short sentence form. We evaluated two different prompting strategies for classification. We had low detail prompts, in which we provide category names and minimal explanation. The motivation for this was it was going to be simple and fast. This is more, I think, how people would actually be prompting uh, a large language model, how to be interacting with it. So, for example, for the abortion post, we said classify each of the posts into pro-choice, pro-life, or neutral. We did not say what those meant. We did not give any more clarity. We just left it as straight as that. For the AP NORC survey, we said classify the survey responses into the top 5 categories it falls into, for example, like economy, healthcare, etc. But we wanted to contrast that with the high detail prompts. We provided category definitions, detailed instructions, and context. Our motivation was clarity and reducing ambiguity for this. So, for example, with GSMA for the abortion one, we included descriptions of the stances. So we decided here's what we mean by pro-choice, here's what we mean by pro-life. We actually provided written descriptions that were closer to what we provided the human coders. So theoretically, this is more similar to the tasks asked of the hand coders than the low detail prompt was. And for the AP NORC one, we included the high level categories and the 100 subcategories. We gave them way more details, so way more abilities to sift through this and to figure out how it was going to classify things. So theoretically, you'd expect those to work really well. We configured, having some issues with the handing off of this. We configured the GPT models to operate with minimal temperature and no repetition penalties. So we've discussed this before. Like, we set the temperature at 0, so there was no randomness. We had no penalty for repeating tokens. We also, which is the frequency penalty, remember the third column down. We also capped the number of tokens it could respond to at 20, which limits the output. That's actually really important if you're doing a lot of calls to an LLM, because the amount of tokens it outputs is costs money. So that's an easy way to keep costs down, is to limit the number you want. And then the presence penalty. So there's no present penalty for the presence of any given token. So prompt engineering results. So here's our results of how this works. So in orange, we have GPT-4, and in red, we have GPT-4o. On the left hand of this figure, we have the GSMA posts with low level of detail and high level of detail. And on the right, we have the AP-NORC posts. And what did we discover? Performance varies based on task and model. There's no one-size-fits-all solution. However, low detail prompts often have better results for GPT-4o. And you see this if you did a low detail prompt, it was never the it was never the worst option. Low level of detail actually gave you better classification in more cases than high level of detail. This is when we think about for the one size fits all solution, but also how you think about prompting matters. When we think actually happens when you provide too much discussion of what these things mean, is these models can overlearn the labels. If you just keep it broad and simple, a lot of times the models itself will have a good conceptualization of what these terms mean and can just rely on their internal logic. Um, so, but that's fine. So in a vacuum, the prompting strategy mattered a lot, and going with a little level of detail is generally a little bit better. But how does this compare to traditional NLP methods? Well, what we found in purple is our best iteration of a GPT model, and in blue is our best performing supervised machine learning model based on traditional natural language processing techniques. And GPT models with no additional training data, so not fine-tuned, not many shot, just simple zero shot, outperformed NLP in every single example we had. And in particular, for classifying the top categories from the AP-NORC survey, AP-NORC responses, the performance was in markedly different. It classified every single abortion post correctly, whereas the NLP models only classified a little over half of them correctly. This is a stunning difference in performance. Now, this is not necessarily going to be true every single time. GPT is not going to outperform NLP to this extent every single time. But in our two cases here, it worked remarkably well. But how did we actually implement this? So this is a little bit of our field note. So this actually goes to one of the questions I was asked. We used GPT instances through Microsoft Azure's OpenAI portal. So that meant we were opening a private instance in Microsoft Azure that we'd set up with our data security, data engineering, and IT teams, in which we already had an existing contract with Microsoft Azure that none of our data was to leave this enclosed environment. And the OpenAI module in there was the same agreement. So essentially, while we're feeding things into a model that lives in this Azure environment, nothing is being exported. So it's a private GPT instance. Our direct calls came from our machines to this. Everything is stored locally. No data left our servers. And this is really important because this is the only way we're able to do a lot of these tasks with the data use agreements we have, with the various concerns about privacy. We had to set up something like this, and these exist. AWS has their own system too. There's a lot of different ways you can configure it, but thinking about data security and confidentiality is very important. So we spent a lot of time upfront thinking about that, and once we had it set up, it was actually very easy to use. So what did we learn? We learned a few big things about about LLM classification for open-ended responses. We learned that LLMs have remarkable accuracy. We didn't show this here in the interest of time, but we had the cost of doing this with LLMs was quite a bit cheaper than actually employing the hand coder, saved a lot of time and money. And it performed better, or we actually, in our whole example, have a lot of sub examples. Sometimes it only matched NLP performance, but the ones here showed that it consistently outperformed NLP performances. The weaknesses are, and this is something we just have to think about generally, there are biases in LLM classification you just don't know upfront. It's going to be much trickier. It's not going to scale as easily as NLP models because each one is a specific call. And yeah, prompting is an art, not a science, as Shobik said earlier. So you have to think about your strategies very carefully, and there's no one size fits all approach. So, all right. And with that, I'm going to pass it over. Shobik can talk about dynamic survey generation.
Great, thanks, Josh. So unfortunately, we actually don't have a ton of time to talk through everything. So what I'm going to do instead is I'm going to give you, I think, quite literally the 30-second elevator pitch for dynamic survey generation. So essentially what we did here that I would discuss in much more detail is we ran a survey experiment on a conversational AI platform, of which there are actually many these days, to test whether AI-based dynamic survey generation, in particular real-time probing, could improve data quality and also to understand the impacts on respondent experience. So I'm just going to speed through what the survey experiment looked like. Essentially, we had a control group that was a series that the survey interview was entirely static. And then we had a series of treatment groups where different styles of AI-assisted reprobing were conducted on the initial open-ended questions. So, for instance, following up to understand, responses that were maybe unclear or entirely junk, asking the respondent to probing the respondent to elaborate on their responses, and then also to confirm whether an initial classification, a categorization of the open-ended responses was correct, essentially allowing the respondent to be a coder on their own response. Okay, so just a kind of speed run through of our results here. So we found three things. One is that we found that the classification accuracy, when we actually did it in real time, was actually moderately strong without any sort of system level prompting or additional calibration of the models. You can see here, for instance, for occupation coding, the classification accuracy was as high as 85%, right? On response quality, we found slightly mixed effects. So it was indeed the case that specificity and explanations in people's responses increased when we exposed them to AI-based probing. And we found finally a small negative effects on the user experience. So when users were in the AI probing treatment groups, we did see slightly higher dropout earlier in the survey. And we did find instances of self-reported frustration. For example, when the large language model misclassified, respondents' answers, for instance, in the media outlet question, we did find instances of frustration. So again, the kind of high level takeaway here in 30 seconds or slightly more is that generative AI can help collect higher quality survey data, but too much we think can create a lower quality survey experience, something to be mindful of. We learned a lot by doing this work. Some of the things we're going to share with you here are that, there are both pros and cons of using survey AI vendors that you should be aware of. Pros on the cost side, cons perhaps on the data usage side. It's worth running a pilot study for the purposes of validation, as Josh mentioned, as one of the principles. In fact, something like what we've done here today could very well serve as that pilot. And the nice thing here is that the data that you get from that pilot can then be used to fine-tune the models that you're using to generate these probes. And finally, and this relates to one of the questions I was asked earlier, we don't have time to get into here, but it is indeed the case that if you're working with an IRB, that you're required to solicit informed consent around AI interaction. So all the respondents in our study here were informed that they were going to interact with conversational AI. And of course, as is the case with any survey project, it's worth carefully considering the user experience. And we could give a whole other talk on this topic. Okay, a couple of concluding thoughts here. Um, you know, so what what are the kind of practical things that you should be thinking about now that you're taking these principles about generative AI to survey research? So I think there are three questions, and we won't talk about the specifics of each one. But at a high level, it's you should ask yourself, why does your project need generative AI? So at what stage, what tasks are you going to be are you hoping that generative AI can help with or automate? What are the costs associated? What are the errors that you're hoping to reduce? What are errors that you think that AI might introduce? How will you operationalize generative AI, right? So thinking about the workflows, thinking about the specific models. Something that we thought about, right, is whether we would host, these workflows internally within on NORC infrastructure versus externally using third-party vendors. And then finally, what is your plan for validation? And again, we don't have a ton of time here. We certainly could spin this off into a whole other webinar, but things like unit testing, things like having a team of human what is often called the practice of red teaming to actually stress test your models. All of these are strategies to validate the models that you're using. Couple of things that we wanted to just briefly, pay some attention to here. One of this, in terms of emerging developments, one of which is what's called retrieval augmented generation. Essentially, it's connecting your large language model to an external database. And so, if we had done this actually in that first example that I showed you of asking who wrote these lyrics, quite straightforwardly, the model could query a database of songs and produce the answer using real data rather than whatever sets of weight matrices and relying too heavily on how it was trained, right? And so you can imagine use cases for this in surveys where it's really important to get the facts correct, right? For instance, if you're asking about real-time news topics, a very exciting, ongoing development is with multimodal LLMs that can switch between textual and audiovisual inputs and outputs and all the other kinds of generation that is possible that we didn't get to talk about today. So you can imagine this for a use case of creating recruitment images for survey respondents that are personalized for individuals based on their demographics or other information that you might have about them. Okay. Really, really quickly, in conclusion, generative AI promises a lot of novel applications, but can also help you do the things that you already do for survey research better, often with less or no code. The secret sauce here is attention. Generative AI, of course, sometimes hallucinates, but there are techniques that can help, such as chain of thought prompting and this development I mentioned of RAG. To apply generative AI to your survey project, consider a number of things that we've mentioned today: the style, content, and scope of the prompts that you're writing, for instance, the exact tasks that you're aiming to accomplish and their workflows, discussing our 3 recommended checklist questions with your team, and finally, consider collaborating with an AI researcher from NORC. We have a wealth of expertise in this, in this area that's only growing, and we'd be happy to help you with your AI use cases, should you be in that position. Couple of additional resources here, and I believe we're going to make the slides available to you, but a couple of writings that we've done on this topic, and also a full study that you can see on the NORC website that actually gives you some more details about that second use case that I didn't get to talk about very much. And finally, if you want to get a sense of the kinds of AI survey work that we're doing at NORC, you can do that as well at this URL. And of course, we will be at APOR/WAPOR in May. So come say hi to us, and we'd be happy to talk more in person about any of these topics as well.
Unsurprisingly, the two of us will be presenting on generative AI in surveys, but interestingly enough, nothing that you've seen here. So all new materials.
Thank you so much
So
to
I think
both
Josh
of
cut out
you.
there. I don't know for y'all, but I think he was going to say interesting. Not a whole lot of. So we'll be talking about some of these topics and other topics as well during our slated talks. But with that, let's open it up for questions from.
Yes, thank you so much, both of you. And Shobik, thank you for the pitch for making sure people come to APOR and WAPOR in May. I appreciate that very much. We only have about 10 minutes, so I'm going to do a sprinkling of questions came very early on in the session, and then also throughout. There was a first question that Christian shared in the Q&A right at the beginning. How reliable is Gen AI when performing these 5 types of tasks? What about validity? I'm concerned about hallucination and other problems when using AI to process real data.
I I think the answer. Can you all hear me? 'Cause I know my mic was having
I
issues
can
earlier.
hear you.
Okay,
Yes, we can hear you.
great. I think the answer is it depends. I think the more straightforward the task, it's more likely to be reliable up front. I mean, there's this great existential questions. What's reliable when it comes to identifying themes in a series of documents? Outside of doing hand-coded validations, it's hard to know. But in general, if you approach it with a good validation strategy, red teaming, all the things we've talked about, you can come up with, I think, an acceptable answer here. And then you can just have to, unfortunately, test it out yourself. There's no one size fits all answer.
Great. Moving on to the next question, one of the more recent questions. Tiago says, thank you very much. My question is about error estimation in the classification of open-ended questions. For example, some strategies using replicas for complex samples with the reclassification of each replica for the selected models after cross-validation. How could this be done using generative AI?
It's a very interesting question. So I think one thing I would stress is if you're using a generative AI model to classify open ends, you should treat it like you're using a natural language processing or machine learning model to classify to do supervised learning on unlabeled documents, which is you should have a holdout sample that you have hand coded yourself and can evaluate against. And you should have an idea of how well it performs in that sample. I've seen approaches that take the error rate from that, and you can bootstrap your own responses with, like, say it's 85% accurate. So you could set up a system where you replicate that 85% accuracy, so the 15% inaccuracy, through models, secondary and tertiary, through the system. So you can replicate the uncertainty from that as you're coding. That's a solution I've seen. I mean, at some level, the answer is you're just going to have to accept that there's a degree of imprecision that you're doing when scaling these things. I mean, to the same extent that if you were using hand coders, you can't guarantee that every hand coder is doing everything correctly every time either. And nor would it be scalable if you could. This is one of those weird there's sort of a philosophy of science question here about how do you know what you know on this. So, I mean, that's sort of principally what I think about. I don't know, Shobik, if you have any other thoughts.
No, I think I would echo everything you said. I would just add that, unfortunately, we didn't get time to dig into it too much, but there are a lot of ways in which you can make your large language models feel smaller, right? I mean, for instance, just by simply selecting a smaller model, but also there are a lot of guardrails that you can implement in addition to like controlling the size of your models. Not least of which is like including a lot of very, very explicit system prompts. Also, the output that you get from a single large language model needn't be the end of your task. There's still a lot of value in having a layer of additional checks, whether that be from you, whether that be from another model, whether that be using pretty straightforward natural language processing techniques like regular expression matching and the like. So these are all things that when you're in the practice of using these things, that you start to develop to kind of build safeguards around that potential stochasticity.
And going into the chat and along the same lines, Jennifer asks, in general, what are the privacy concerns about using Gen AI on proprietary data?
Yes. Tremendous. It's why, and I wanted to make sure to work in the example of mine that how we did it with the Microsoft Azure environment, because that was probably the single biggest thing that was holding up more widespread adoption at NORC. Was we take privacy and data security incredibly seriously. So finding a solution that adhered to these principles was of the utmost importance. So that's the most conventional. That's the most straightforward way to use commercial models. The other way would be to use open source models and host them locally. We didn't get into that today. Happy to talk about that. Feel free to send us a message or something if you want to get into more details. But essentially, you can host a version of a large language model locally on your own machine. Good luck with your compute that it will take. And then none of the data ever leaves your machine. Those models tend to be a little more unwieldy than the user-friendly GPT models, for example, but you have complete confidence that your data isn't going anywhere and you can completely reproduce your answers every single time. So for replicatability, it's a pretty good solution. But yeah, Shobik, do you have anything else you want to add or?
No, I think that covers it.
Okay.
Hey, Colin has a question about demographics. He asks, can you say something about how you work with demographics for input, output, and analysis?
Yeah, I mean, I think it depends on the exact application. I don't know, Colin, if you had a specific one in mind. I mean, I can start by saying, you know, for this example here of generating the personalized learning plan, when we did so in this you know, this demo, part of what we sent off to the LLM here via the system and user prompts were this information, this background information about, you know, the respondents' LLM background and their learning goals, which I think is in an earlier slide. Yeah, so this stuff here, these are things that are helpful. Depending on your use case, they may be less helpful. Depending on your use case, they may be entirely prohibited based on your data usage agreement with the client or, you know, with whoever you might be doing this work for. So I think it varies a lot, but there are certainly applications where it is, you know, you may be able to use it, and it is helpful in generating the outputs in a personalized way in particular.
Okay, we are in the last 2 minutes, so I think this may be our last question. And I thought we may start with something that's what Jorge thought may be controversial. Do you envision a time when an AI agent tool would be able to conduct a complete survey research process from planning through PDF generation to presenting the results to the customer, all by receiving human input through voice only? If so, the company would need to work heavily in having the panels ready to answer only. A provocative question to end our session today.
I don't know. We have not pre-discussed this, but I will say I will upfront register. I don't think that will be happening in the near future. I don't think you can reliably count on generative AI to not skip steps, to satisfy, if you want to use survey parlance, um, and to cheat throughout this. A great example, one of the most powerful research tools out there in Gen AI right now is the deep research tab, options that are now built into OpenAI and a few others. I saw a wonderful discussion of this on Twitter the other day, where they had it perform a task of assessing demographics of authors in mathematics journals. And as it turned out, the LLM lied about how it got its data. And yeah, I've always analogized LLMs as enthusiastic, very smart, but not terribly honest first-year graduate student research assistants.
That's a great analogy. Showbeck, any comments from you?
Yeah, I mean, I would agree with that. Hence why the core of this, you know, this webinar is this task-based perspective, right? It's a task-based perspective. It's not a project-based or like, you know, survey research altogether based, you know, perspective of, and going back to the, you know, the kind of starting remarks to frame this, you know, we're not automating humans away from survey research, and we're not automating away survey research. So,
All
Yeah.
right.
The,
Yes. Oh, go Josh. Josh, please.
oh, and actually one more thing I actually saw last night a paper on there was a paper a few months ago that was like, oh, can LLMs generate more novel ideas in science than humans? And they had this great experiment. And someone did a follow-up on that. They actually followed through what the novel ideas that LLMs are generating. And as it turned out, all the novel research ideas were plagiarized from existing working papers. So again, tread lightly, use with caution. There's lots of things it can do well, but if you are relying on an LLM to generate anything new, what I would say is LLMs don't create from scratch, they interpolate. They fill in the spaces between existing language points, and then they figure out the most interesting and useful ways to do that. It's not going to create something new. And boy, if you submitted a plagiarized research concept based on an LLM, you have no one to blame but yourself, because you can't blame the computer. You can't fire them.
Words of caution, and it was so inspiring. And thank you so much, Josh and Shobik, for being here today to share with us. So interesting. And as Shobik said, please come to WAPOR and APOR. If you are still debating, we look forward to seeing you there. And so grateful for everyone joining us. We had close to 200 people here at one point. So what a wonderful day to start the day. Thank you again for joining us. Thank you, Josh and Shobik.
Thank you, Alice, and thank you, WAPOR, and see you all in May.
Yes.